Ag Mag Soil and Water. Soil and Water Math. A milking dairy cow drinks a bathtub full of water, about 40 gallons, every day. How many gallons does she drink in 1 week? In 1 year? The fact you'll need to know for the last part is there are 52 weeks in a year. Number 2, a farmer is irrigating crops, but 45 gallons of water are leaking from the pipe each day. How many gallons are lost each week? Number 3, nature requires about 500 years to build 1 inch of topsoil. How many years are needed to develop half an inch of topsoil? 4, in North Dakota, about 2/3 of soil erosion is caused by wind and the rest is caused by water. What fraction is caused by water? 5, washing 1 load of clothes takes about 30 gallons of water. If your family washes 8 loads a week, how many gallons of water are used? 6, a 10-minute shower uses about 30 gallons of water. If you cut your shower in half to 5 minutes, how many gallons of water are used? For number 7, you will need to know that 1 quart equals 2 pints. Leaving the water running when you brush your teeth uses about 1 quart of water, same as 2 pints. Turning the water off uses about 1 pint. How much water do you save by turning off the water? If you brush your teeth twice a day, how many quarts do you save in a week? Okay, so they're asking you how much you save, and then the next one is how many quarts do you save? Okay, so the first answer label is pint, and the second label for the question is quarts. 8, many water-efficient toilets use 1.6 gallons of water per flush. If each member of the family of 4 flushes the toilet 6 times a day, how much water do they use with a water-efficient toilet? Okay, so think about how many people are in the family, how often it's used, and how much water. Before 1950, most toilets used 7 gallons of water per flush. How much less water is needed per flush with today's water-efficient toilet? Okay, that's going to take some thinking. So take your time and do your best there. Sizing up soil. Soil consists of various sized particles, with sand being the largest, silt the next, and clay the smallest. By comparison, think of sand as the size of a basketball, silt a baseball, and clay a marble. So think about proportions. If you made one way too big or way too small, the other way, this visual wouldn't make sense, right? So this is a huge reason why proportions are so important. Air spaces are between these particles. Soil must contain at least 12% oxygen for roots to grow. If soil is compacted, the particles are pressed together, leaving only 2 to 5% of the necessary oxygen in the spaces. Page 5. Plants need soil. Plants absorb nutrients from the soil with their roots. Their roots also drain water from the soil, which keeps the soil from staying too wet. Roots help make soil too. They split rocks into pieces that later become soil. So here are the soil layers, and you'll need to label them off to the side. The B horizon, also called the subsoil, it contains clay and mineral deposits like iron, aluminum oxides, and calcium carbonate. It receives, oh my word. Okay, let me start over. B horizon, also called the subsoil, it contains clay and mineral deposits like iron, aluminum oxides, and calcium carbonate that it receives from layers above it when water drips from the soil above. There we go. R horizon, the unweathered rock or bedrock layer that is beneath all the others. O horizon, organic layer of soil made up mostly of leaf litter and humus, decomposed organic matter. C horizon, slightly broken up bedrock. Plant roots do not penetrate into this layer, and very little organic matter is found in this layer. A horizon, the layer called topsoil. Seeds germinate and plants grow in this dark colored layer. It is made up of humus, decomposed organic matter, mixed with mineral particles. So be very careful on that one because it can be a little bit misleading. Page 6. The dirty 30s to today. Okay, so page 6 has 4 pictures, and you're going to use these 4 pictures with the text here. Okay, the next page, those 4 pictures stay on that page. So you're sticking on one page at a time here. The dirty 30s to today. Erosion is the process of breaking things down. In agriculture, chunks of soil are moved by water or wind and broken into finer soil that washes or blows easily. During the Dust Bowl of the 1930s, strong winds blew dry soil and caused it to move considerably. Though the southern plains were especially impacted by the Dust Bowl, North Dakota suffered from reduced agricultural production and declining population. After the Dust Bowl, farmers and ranchers became more aware of the need to practice more soil and water conservation techniques. Match the graphic to the term that describes a conservation technique to reduce wind erosion. Vegetative wind barriers are strips of perennial or annual grass planted to hold soil in the ground. Living snow fences, a line of short trees, shrubs, crops, and/or native grasses, primarily along roads that trap snow as it blows across fields, piling it up before it reaches the road. Reduced tillage farming. Any farming method that keeps tillage operations to a minimum and leaves at least 30% of the soil surface covered with plant residue after planting to reduce soil erosion by water or wind. Windbreak or shelter belt. Rows of trees that protect a farmer's homestead or reduces wind erosion in farm fields. Page 7, water erosion. The erosion rate by water on U.S. croplands has been reduced by 24% in the last 15 years. Match the graphic to the term that describes the conservation technique. Contour farming. Planting alternating strips of crops across the slope of the land. The strips usually alternate between a row crop like corn and a solid seeded crop like wheat, barley, or alfalfa. Terraces, a series of step-like contours in fields. Each step slows the flow of water runoff, slowing the erosion process. Dam, an earthen or concrete structure to stop water flow, to trap sediment, stabilize drainage ways, and reduce erosion. Store excess water temporarily to reduce flood damage, or store water for livestock, irrigation, household, or municipal use. Grassed waterway, seeded grass in areas of a farm field prone to heavy water erosion or gullying.